Hello dear students, today we will discuss how to write electronic configuration. So as we discussed Abahu principle yesterday, and according to Abahu's principle, electron will always fill in increasing order of energy of suborbits. So that's why I have represented increasing order of energy of suborbit here, like 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. They all are in the increasing order of energy. So according to Abau's principle, if you want to write electronic configuration, you have to follow this order. Okay, you will fill electron in 1s orbit first, after that in 2s suborbit, after that in 3p suborbit, after that in 3s, and so on. Okay, and one more thing, as we know that one orbital, one square box can have maximum 2 electron. Okay, one is of clockwise spin and one is of anti-clockwise spin. And since s suborbit has only one orbital, one square box, so how many electron s can have? 2 electrons, because one square box can have 2 and s have only one orbital, so it will have maximum 2 electron. Now for p suborbit, since p suborbit has 3 orbitals, okay, and one orbital can have 2, so how many electron p will have? 3 into 2 means it will have maximum 6 electrons. Again for d, since d has 5 orbitals, so because of the presence of 5 orbital, it will have 5 into 2 equals to 10 electron, maximum 10 electron. Now for f suborbit have 7 orbitals, and for 7 orbitals 14 electrons can be here. Okay, so because of the presence of 7 orbital, it will have maximum 14 electrons. Okay, now start electronic configuration. Suppose we want to write electronic configuration for hydrogen. Since hydrogen has 1 electron, because its atomic number is 1. Okay, so for the distribution of 1 electron, obviously we will follow this order. So we will start from here. We will use 1s suborbit first, so we will write 1s. Now in 1s orbital, how many electrons we have to distribute? Only 1 electron, so we will write 1s 1 only. Okay, why 1? Because we want to distribute only single electron. Now for helium, helium has 2 electrons, so to write electronic configuration for helium, again we will use 1s orbit first, so 1s orbit, and we will write 2 here. Why 2? Because it has 2 electron. Okay, so we have to distribute 2 electron in 1s orbit. Now for lithium, lithium has 3 electrons, so for the distribution of 3 electron, we will use this order, and in this order we will start from here. So 1s we will write, so it has 3 electrons, so we can write 1s 2 here, but we can't write 1s 3, because as I already told you that s can have maximum 2 electrons only. So that's why we will write 1s2, and for the left electron, for the remaining electron, we will use new suborbit, which is 2s here. Okay, so 2s1. Why 1? Because we have only 1 electron left, that's why we will write 1. So the electronic configuration for lithium is 1s2 2s1. Now for beryllium, beryllium has 4 electrons, so for the distribution of 4 electron, again start from here. 1s 1s2, because it has maximum capacity of 2 electron only, so 1s2 only. Now we have 2 electrons remaining here, so we will use 2s, so 2s can here again s is coming here, so for s suborbit, as we know that it can have 2 electron, so again we will write 2 here. So electronic configuration for beryllium is 1s2 2s2, 2 plus 2 4 here. Now for boron, boron atomic number of boron is 5. So for the distribution of 5 electron, 1s2, 2s2. Now as we have to distribute 5 electron, okay, and by writing 1s2 and 2s2, we have already distributed 4 electrons, but 1 electron is remaining here. So for the remaining electron, we will use this new suborbit, which is 2p here. So we will write 2p1. Now for carbon, carbon has 6 electron. So for 6 electron, 1s2, 2s2 and 2p. 2p, in 2p we will fill 2 electrons because we have only 2 electrons left, but we can fill 1 to 6 electron in p, okay. That's why for nitrogen I have written 2p3, for oxygen 2p4, for fluorine 2p5, and for neon 2p6. And after writing 2p6, we have to use new suborbit because p can have only 6 electron. So if you want to write electronic configuration for sodium, like 11 electrons are here. So for sodium, 1s2, 2s2, 2p6 only, okay. We can't write 7 here because p has maximum capacity of 6 electron. So after writing 2p6, 1 electron is remaining. So for this 1 electron, for this remaining electron, we will use new suborbit, which is 3s here. So 3s1 we will write. So electronic configuration for sodium is 1s2, 2s2, 2p6, 3s1, okay. Again for magnesium, 1s2, 2s2, 2p6 and 3s2 instead of 1, because in this case we have to distribute 12 electrons. You can check 2 plus 2 plus 6, 10 plus 2, 12, okay. Now for aluminium, aluminium has 13 electrons. So 1s2, 2s2, 2p6, 3s2. Now 1 electron is remaining, but as we know that we can't write 3s3 here because as the s has the capacity of 2 electrons only. So for the left electron we will use new suborbit, which is 3p here. So we will write 3p1 because only 1 electron is left here. Now for argon, we can write 1s2, 2s2, 2p6, 3s2, 3p6, okay. I skipped some element here in which 3p2, 3p3, 3p4, 3p5 will present, okay. Now for potassium, it has 19 electrons. So again for 19 electron, 1s2, 2s2, 2p6, 3s2, 3p6, okay. After 3p6 we have distributed only 18 electrons, okay. So 1 electron is remaining. So as we know that we can't write 3p7, so we will use 4s. So 4s1 we will write because only 1 electron is remaining, okay. So again for calcium, it has 20 electrons, okay. So for the distribution of 20 electrons, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, because s can have 2 electrons. Now for scandium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, but it has 1 electron extra than calcium. So for the extra electron we will write 3d1, okay. Now for titanium, titanium has 22 electrons. So for 22 electron distribution, we will write 1s2, 2s2, 2p6, 3s2, 3p6, 3d2. After 3d1, for titanium we will write 3d2 because it has 22 electrons and scandium has 21 electrons. So 3d2 and 4s2. Now for vanadium, 23, 1s2, 2s2, 2p6, 3s2, 3p6, 3d3. After 3d2, 3d3, okay. So we can fill the electron until it has 10 electron. But here chromium and copper is exceptional cases. as for chromium it has 24 electrons, so its expected electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d4, 4s2. Okay, because it comes after vanadium, and vanadium have 3d 3 electrons, so obviously for chromium we have to write 3d4, but its actual electronic configuration is this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Okay, so this case, and again for copper, expected electronic configuration for copper is 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s2. Okay, now but it shows the electronic configuration like this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. Okay, so for time being, remember these two cases, and what is the reason of this behavior we will discuss in another video. Okay, so remember these two. Now I hope now you are able to write electronic configuration of any atom by using this order, okay, according to Abahus principle. Thank you.